It's day two. I was listening to Two Chains right now, and it's in my mind. Money is the motivation, money is the conversation. We are on vacation. We got peso. We are on vacation. It's the life I chose. Gunshots in the dark, one eye closed. Okay, day two, day two, day two. Ah, I should have added. Uh, I did not add a thumbnail. It's the life I chose. Gunshots in the dark, one eye closed. I love this song. Hello, you guys. Hello, 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 hello. Uh, hello, my zero viewers. uh, there's this guy like, uh, one minute, one minute. I had to do something. 1 minute. Okay, where were we? There's this guy Vidit Goyal, and a huge shout out to him because he has been a good hype king. Been hyping me over to and staying motivated. So thank you, Vidit. Thank you for being there, and we'll just continue from where we left. We read this article. I think these articles are very similar, like by the names they look very similar, so I think we'll just skim through them. We can't go over like how internet works, like over and over and over again. uh, so, because how does the internet work? The internet explain. How does the internet work? Introduction to internet. How does that's just dumb to read everything again and again. And the main goal is to know the basics. As you develop as a programmer, if you know stuff, okay, this is this, okay, this is this, you will grow. Like, okay, so the internet explain. Don't think we'll spend a long time here. Yeah, so this is where we left yesterday. Yesterday, we finished this, we opened this, but yeah, the internet is the world's most access. Yeah, what is the internet? Last mile data centers, the backbone. We know, so okay, let me tell you, the last mile is the part of internet that connects homes and so basically it's end to end, like it's like internet is from every device and it goes almost everywhere. Okay, there are places that where there is no internet, but like the it goes to the end users. It goes from the end user to the end user. Data centers where you store the data centers, the backbone, fiber optics cable, uh, edge point, exchange points, like your, I think, the global router, I think what they are talking about, all your IP routers, like ISP, Internet Service Provider. ARPANET, we know that, and we don't need to know who created the internet, whatever, whoever did. Like, I know it's good to give people that they create respect of that and the recognition they deserve, but it does not make us better, so it doesn't matter. Did AI go in the I'll go. Oh, vice president, no. Who runs the basically I know all these topics. I know like Al Gore was some guy who was running for presidency in US. But now, right now, who runs the internet? Now, this is something that is important to us. So, no one runs the internet. It's organized or as a decentralized network, thousands of companies, universities, government, etc. Organizations, basically. Technically, let's share technical standards to make internet work are managed by an organization called Internet Engineering Task Force (IETF). Open organization. Anyone who performs on this standard. That's company based. Cool. Connect corporation of a world. ICANN. ICANN is basically domain names for distribution. Like works on then it doesn't control who can connect to the internet. Okay. Or what kind of ICANN is used for ICANN is basically the organization that keeps the registry for domain names. So yeah, there are many domains providers, but at last the management of domains like the hash table, basically like in very simple term, hash table is stored by ICANN. What is IP address? We know we saw what is IPv6. Okay, current internet IPv4 currently 4 billion IP addresses. Today it's very less. 4 billion is very less. So IPv6 now was developed. So it has 39 digits. So uh, basically now if with IPv6 the world would never run out of IP addresses. Uh, okay, first transition was slow. Now then serious chicken and egg problems. Okay, yeah. So what is chicken and egg problem? That uh, let's say you are starting an organization and now you need customers for that organization, but before having the customers you need a product, but you the product should but for selling the product you need customers. So now which side would you focus on? So like if you have demand side, you can focus on generate the customers, then create the product and then deliver them, or you can make the product, take that risk, and then go to and make customers or find customers. So this is the chicken and egg problem where like IPv6 was developed. Now you have developed IPv6. So now people are using IPv4. So how would you make them use IPv6? So that is basically the problem. Like uh, first you will find people that uh, like what should you do first? Like what uh, is the first thing to generate? Then IPv4 addresses start it uh, like finishing like scarce became scarce, and IPv6 grew. Connect to Google by now 6% of the user connects to Google via IPv6. How does in 2015? So like now it will be all on. Let's see now IPv6 adoption. V6 adoption. 40% of the users now use IPv6. India is around 68, 69% India. 69. I'm just, uh, I think I'm quite happy there. It's like, it's weird. Like, this is something I think, like, normally if what's my emotional state? But it's very weird thinking about this on the stream. Um, there are two types of wireless internet access. Wi-Fi and cellular. Wi-Fi networks are simple, relatively simple. Anyone can purchase Wi-Fi network equipment and provide. Yeah, cellular networks are more centralized. They work by break. Okay. Uh, cellular networks are more centralized. They work by breaking up service territory into cells. In the densest area, cells can be small in as single city blocks. In rural areas, cells can be miles across. Each cell has towers. By centering it at its center, provides service to devices there. When a device moves from one cell to another, the network automatically hands off the device from one tower to another, allowing the users to continue communicating through interruption without interruption. Sorry, that sorry was very Western. Cells are too large to use. Cells are too. Cells. I'm getting too comfortable on this stream. Uh, Cells are too large to use the unlicensed low power spectrum used by Wi-Fi networks. Instead, what the fuck is this accent? Instead, cellular networks use spectrum licensed for the exclusive use. Because this spectrum is scarce, it is usually awarded by auction. Wireless auctions have generated tens of $billions for revenue users. I don't like I don't like this US centric view of technology because auctions happen in India. Why would you only talk about US centric auctions? Okay, I know they happen in the US, but what the fuck about my country? Uh, mm, what is cloud? Cloud describes an approach of computing that has become popular in the early 2000s by storing files on server and delivering software over the internet. Cloud computing provides users with simple, more reliable compute service. Cloud computing allows consumers and business to treat computing as a utility, leaving technical details to technology companies. Yeah, true. Cloud was cheaper though. Right now, metal is becoming much more cheaper. So this is something. If you are developing your own cloud company, obviously not at the beginning. Like if you're developing your own company, obviously not in the beginning, but in the longer run, you should prefer. Like you would like to look at bare metal, setting up your own data centers somewhere like in the hire a company not set up hire a company that set up your own data centers and that's turning out to be a lot cheaper than the cloud because and a lot more performant because then there's no virtualization of computing and network calls like the network is faster so for example, in 1990s, many people used Microsoft Office to edit documents and spreadsheet and store documents on their hard drive. And yeah, now Google Cloud Docs is a Office suite free. Docs.com was the file stored Google servers are available on each computer. Microsoft now has own crossover Office 360. There are many other examples. Gmail and Hotmail are cloud email service that have largely replaced desktop email clients such as Outlook. I I don't understand. I don't understand email. Uh, the way I see email is like a messaging service. Like you have one data that goes from here to there. So I don't understand this primitive view how email was before Gmail. So I think because I haven't seen that technology, never experienced that technology, and so like why is email so much hyped as a way of communication, and why Does it have a very separate look? When I feel email is just like a message where you send someone an email, they reply back, you send another email. So that's kind of odd to for me to understand. Dropbox, cloud. Yeah, we know Dropbox, Apple iCloud. We know cloud computing is having a big impact on business. They didn't talk about AWS. That's weird. Oh, they are talking. But in 2006, Amazon is having a big companies wanting to create website needed to purchase and operate their own server. AWS, which allowed customers to rent servers by and all, that has lowered a barrier of entry and creating websites. This is not true. Customers don't rent servers by, they run virtualized computing power. So, like, it's not actual physical server. Okay, this part of the server is yours. It's basically computing power. That's what I think. I may be wrong. So, what is a packet? It's just a data. It's a unit of data, splitting information. Small digestible piece. Yeah, packet super header contains data, like information source destination checksum value. See, detective package was damaged or in the transmitter. Other headers come with actual data. The packet can contain up to 64 kilobytes of data, which is roughly 20 pages of plain text. Ooh, never like quantified that data, and right now it seems like a lot. 20 pages is not small. But like 64 KB seems like very small, but 20 pages is a lot. If the internet router experience congestion or other technical problems, they are allowed to deal with a simple discarding package. It is sending computers with responsibility to detect the packet didn't reach its destination and send another copy. This approach might seem counterintuitive, but it simplifies the internet core infrastructure, leading to higher performance at lower cost. Whatever. www. Tim Berners-Lee, CERN, computer programmer, user-friendly interface, then other internet application, the web supported hyperlinks, yeah, everything. Over the time, the web became increasingly sophisticated and everything like we know. W3C consortium be the web's official standard organization. W3C directors and continues to oversee develop web standards. Web is an open platform and W3C can't compel anyone to adopt its recommendation. In practice, the organization with the most influence over the web is Microsoft, Google, Apple, Mozilla. I don't know. Mozilla could be very powerful on the or like web overall web scale. Exactly, that is true. Any technology that they adopt. Nah, gRPC is like very high, but it's not a web standard. But they never tried to make it a web standard too. Whatever. Web has been so popular that many people now regard it as synonymous with internet itself. But technically, web is just one of many internet applications. Other applications include email and Twitter. I don't understand email. Somebody please explain me what is email? Like how it is like how is it different from messaging and like sending message, and why it is like it's a entire protocol? Why is it an entire protocol? Why can't it work on the web itself? Web browser, we know, leave it. SSL we saw last time. Let's see, secure software. Secure look supposed to say. Uh, Let's keep okay. I don't care whoever introduced it. No, no, it's a future version. Yeah, DNS we saw last time. System is hierarchical. For example, .com domain is administered by a company called VeriSign assigns subdomains like Google and Vox.com. I am so frustrated with .com domains. I can't even tell. Um, I have tried to buy two domains, hashtag.com and this is uh, this is something else I have been working on, and it's just shit. Both of these sides, and also a third thing that I think I'll work on in the future, and it's just shit. Anything I search for in the registry, I generally buy through Cloudflare. Flare. Um, it's not available. It's not available, and then you try to check out. Okay, what are they doing? Are they making something nice? Are they actually using it? No, they are not using it. It's just there. They have some random guy thought that okay, these are very generic names. Somebody in the future will buy them because hashtag is what is hashtag. It's S and a hashtag, and it resembles my name. So that's hashtag. Uh, my other name is also a pun. Basically, it's a pun on something. So and the third name I actually could find it. So I'm not very angry about it. But for the third application I was this was the third name that I came up with, and that's what I found. There were two other names that I did actually came up with and which I could not find on the .com domain. So I'm just angry that these people just buy up hold and hold the domains, and then nothing. It's not like it's $10 per year something, and they keep it for years and years, and then it's no value for them, but they just hold it in the hopes that somebody out there will make something big. Like I could make trash, like I bought trashtag.uk, so I could make like for my portfolio. So someday if trashtag.uk gets big enough, then I might try to buy out trashtag.com, and that's their hope, and which is something I don't like. If somebody is not using their domain, they should not be able to keep it after a year. For a year, like somebody should like I know will be problems like okay, so what if someone just at the end of the year hosts a website or hosts a blank page or something? But at least like there should be some solutions that could should be thought, because this hoarding is something that I hate. I hate it. Uh, who decides what domain name exists and who gets them? I can non-profit funded, yeah, thoroughly over DNS by U.S. Commerce Department, though it has increasingly asset from U.S. government. Two types of domain name. The first is generic TLD, such as .com video, .com. The internet, three domain tend to be most popular. There are also country-based TLDs, two letters each country. .us, GB, oh UK, sorry, GB. Some country has GB. I think there is a domain called GB. Some CC. Yeah, Tuvalu has .tv. Twitch.tv is actually Twitch.tuvalu, not television. Are you British Indian Ocean Territory? Um, make it easier to create. Yeah, it doesn't sound. Okay, cool. You support Vox? No, I will not. uh, I want to make a top level domain. how to make my TLE non-profit. Can I register? It's not free. It's not free. Oh, dumb. Anna Fitzgerald, you are fucking dumb. You buy it for $18. Free to tens of $1,000. Free to tens of $1,000 is not free. Oh, yeah, sorry. It's a, it's not free. Yeah, it's not free. It's like on Wix.com. It's their it's the last secondary domain is there for 1 year. The next year charges are higher on these sites for like free for 1 year. Leave it. Uh, how to register your my own TLD. Any established public or private organization. Cool, no problem. Cool. Uh, Now we have read two articles. How much time? It's half an hour. We'll go for half more. Uh, but we'll just skim through these. I think we know a lot. I like sites like this, like very simple, very plain, very informative. Introduction, where to begin, interest, and then asset, address, IP, I guess. Protocol stacks and packet application protocol layer application transmission. See, let's start from physical layer, data link layer. I don't remember everything. Networks layer, there are seven. In the OSI model there are seven. uh, Physical data link layer, network layer, I guess transmission, session, presentation, application. Did I get it? 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 Let's see. OSI model application. Physical data link layer, network transport layer. I said transmission instead of transport. But yeah, session layer, presentation, application. Like I just missed the fourth one by some, and it means the same. Transport and transmission are very similar words. I think almost the same, synonymous. Okay. Application layer, transmission control protocol, TCP. It's not OSI model that they are talking about though. Talking about protocol stacks and packets, it's kind of that. Like it's OSI model in a very brief network infrastructure, your computer, LAN, router. I should turn that off. No. Let's do this. Arc has this very great feature. You can do this. Oh, no. E- e- Now let's change it to. Do we like blue? We like something that is light on the lighter side. Blue is okay. Uh, is it? Yeah, this is better visibility. Cool. No, actually, don't like it. Not bad. Not bad. Not bad. Okay, this is good. Good enough. At least things are visible. So you know how packets travel from one computer to another. Yeah, this is internet infrastructure, ISP, local ISP, regional ISPs, and then national level ISP, and then there are internet routing hierarchy, national service provider backbone, regional ISP, local area networks, domain names and addresses origin, root org, then top level domains, and then nasa.gov.in, like in India, I guess in it, .in. Internet protocol revisited, application protocol. Yeah, we know we have learned about HTTP and everything. Protocols, SMTP, simple mail transfer. Why do we need a mail transfer protocol? Why can't mail work on HTTP? Why do we need a mail? You can HTTP post to send mail within your own setup, but billions of email servers and billions of mailboxes across the globe follow to protocol. Okay, okay. It has differences. You can do it just because it's not used, it's not used. TCP, we learned about TCP. Uh, I think this article is something that we should look much more deeper, but with boost. I like this one better. I've never tried this. Okay, infrastructure, network, internet infrastructure, internet routing hierarchy, almost the same. DNS uh, protocol. Let's read about this. Let's read about SMTP because that's what I don't understand. And the rest of them we have read like in previous articles. Another commonly used as SMTP text-based protocol, unlike is connection oriented. This is more complicated than HTTP. There are more commands and consideration in SMTP. There are mail client, mail client, video email. This is what's typical. Mail client opens the connection to default mail server. The mail server IP addresses are domain names. Is typically set up when the mail client is installed. The mail server will always transmit the first message to identify itself. Cool. Mail client will send SMTP hello message to which the server will respond 250 OK message depending on whether the client is checking mail sending appropriate. The request response transaction will continue until the client sends SMTP quit command. The server will say goodbye and connection will be closed. This is how mail from okay 250. 250 is okay. That's kind of different. HTTP 200 is okay. TCP, we learned about TCP. Yeah, let's about the TCP is textual protocol. TCP connection window. When TCP layer receives the application layer protocol data from a void, segments into two manageable chunks and then add TCP header with specific TCP information to each chunk. The information contained in the TCP header includes the port number and application of data needs to send. When the TCP layer receives the packet from IP layer below it, the TCP layer strips the TCP header from data packet, some data reconstruction if necessary, and then sends the data to the correct application using the port number taken from TCP header. 16-bit source, 16-bit destination, 32-bit sequence number, acknowledgement number, miscellaneous data including header length, window size, checksum. Cool, no problem. TCP does not have IP. IP data. This is IP packet. I have learned about this all in uni, but I don't remember a lot. IP header, TCP header, and then data from application layer. I think this is the this this data I think is this whole I guess. Yeah, cool. That's how we are gonna skim. And that's what I said. Skim. How wires and cable, IP address and DNS, packet routing. This is all what we have seen in previous. This is what I hate. Why doesn't it open in a new tab? Hmm. Chrome has this good thing. If you open a tab and you close it, uh, then if you close the tab, it goes back to the, like if you press back, it has the back option. It has the history saved with it. Does not have that right now. I think we did this. We full course. Should we do the full course? Hmm. Should we do this? Should we do this? It's 1 hour 42 minutes long. It's actually 2 hours. Like if we do it in 2x, we'll do it in 50 minutes. Let's do this. Let's me add it. Add a source. Let's see. No, this does not work. Huh, these settings. I would have to go into a mode that kind of sometimes does not work. Let's just go there. Screen capture. It kind of does not work because I will have to bring it to the Mac from the iPad first. Streamlabs has some bugs. It's not the best thing ever, but better than OBS. Like it's built on OBS on top of OBS. So, like obviously they did some work and it's very Kuyo with the stretch. Also, Warren, Jackson, Jackson, Mississippi.
Ian Frost teaches this course with tons of visuals, just like he has taught thousands of people on Udemy.
The internet is a part of our daily life and we use it constantly. But what is the internet? Have you ever really thought about it? Have you ever wondered what happens in the background when you enter a web page? If your answer to all these questions is yes, you are definitely looking at the right course. In this course, I assume you don't know anything, and I am slowly explaining what the internet is. You don't need any prior knowledge to follow this course, since this course tells you everything from scratch with many abstractions. No, it's basic cables spread all over the world, and in this course, we will go on a journey together, and we will look at all these concepts in a very visual way. I'm explaining them. You can benefit from this course at the maximum level, okay? Regardless of your age or profession, this course is for everyone. Now, we are going to talk about a scenario. Let's say you are the system administrator of a small company, and your boss wants you to enable all these computers to communicate with each other. I mean, PC1 should be able to communicate with PC7, or PC5 should be able to communicate with PC4, and so on. You got the point. But the question is, how do we do such a task? And this is where the switch device comes into play. The switch is the device we use for computers in the same environment to communicate with each other. When I say in, and this scenario is a good example for such a situation. There's an office, and in this office, we have 7 computers that communication of them is required. Wonderful. We have a switch to accomplish the communication of computers. This is good. However, the question is, can these 7 computers communicate with each other right now? And the answer is big. I have some ideas, and you are probably guessing right. We must use cables to connect computers, and the type of these copper cables can generally be Cat5 cable or Cat6 cable in small environments. By the way, Cat6 cables are faster than Cat5 cables, and Cat represents category, okay? On the other hand, in addition to copper cables, some switches support fiber optic cables as well, and it is important to note that fiber optic cables are generally much faster compared to copper cables in data transmission. This is very important. And for switch devices, there is a crucial point to be aware of. Please note that if there's a switch in the environment, and if you want to connect computers to that switch, we must definitely use a cable that is generally a copper cable or fiber optic cable. What I am trying to say is, with wireless technology, you cannot connect computers to a switch. Switches only work with cables. This is very vital, guys. If you want to use a switch device, you have to use cable to connect your devices to the switch. It's that simple. However, if you want to connect computers in the same environment to each other by using only wireless technology, you can use an access point device instead of a switch device. I mean, you can use both a switch device or an access point device in order to connect all the 7 computers. Both of them separately is acceptable for this purpose. The only difference between these devices is access points use wireless technology while switches use cables, okay? There are 7 computers in this environment, and we can connect these 7 computers by using switches and cables, just like you see in the picture. Or, in the same way, we can use an access point device instead of a switch device, and if we use an access point device, access point uses wireless technology instead of cables while communicating with devices. In summary, both the switch device or an access point device enable these 7 computers to communicate. This is obvious.
I don't know how his voice is in normal speed, but
But one uses cable, and the other one uses
voice is very high pitched.
wireless technology. Anyway, what I just want you to know right now is we generally use copper cables in order to connect computers to the switch in the environment such as a home or office. By the way, I want to focus on the switch device instead of the access point device in this course. Very good. And at this moment, all these computers can communicate with each other with ease because they connected to the switch by using cables, and this means that they created a network. In other words, the reason that these computers can communicate with each other is all of them are in the same network, and we call this special network as local area network, or briefly LAN. If you want to create a LAN, this location must be a restricted location in terms of area. Area is a very suitable area in order to create a LAN. Therefore, these computers can communicate with each other because all of them are on the same LAN. We can create a local area is. You might think that all the houses in the world are actually a local area network. You have a LAN in your house, or your neighbor's home also has a LAN, or there is and what this event actually represents. Let's say PC1 wants to send, and some people call them as frame. Both of them is okay, but in this course, I prefer to use packet instead of frame. Okay, PC1 will send a packet to the PC6. As you see in the visual, the packet first goes to the switch. The logic is basically this. If a computer, this information is so crucial, guys, okay? However, maybe by looking at only this switch image, what the switch device actually is may not be fully visualized in your mind. For this reason, there are many ports on a switch device. This is important. Also, switches have 10 ports, while some switches have more than 20 ports. And, of course, this generally leads to an increase in price, because as you know, we create LANs. To these ports, we can create a LAN and ports. You can see the related visuals on the right side. Switch, we connect the LAN port on the computer and the LAN port on the switch with the help of after that. Let's connect. Currently, this computer wants to communicate with PC4, so it will send a packet to the PC4. This packet will go to this port of the switch first. Look inside. Finally, the switch sends the packet to the switch. This means good so far, and the switch device is visualized better in your mind thanks to this slide. But communication between those devices, we have never talked about how these computers can connect to the internet, right? Question that we are looking for an answer. In our previous lesson, we briefly talked about how to
This guy repeats a lot of things.
connect computers in an office, and how do we create a network? And I said that we can create a LAN with the help of a switch device. Of the switch is to create a LAN and enable the communication that there's a LAN here. The other device comes into play. Let me to the internet. And in order to provide this connection, in order to provide a connection to the internet, first of all, we must connect this switch to this router. And this cable is a copper cable, just like other cables. This is good, but currently, what we have to do isn't over. We still can't connect to the internet in our offices, and this cable is given us by internet service provider. And thanks to this cable, we connect to the internet. If you have never heard of internet service provider, don't worry, we will talk about it in detail. But for now, all you need to know is the internet service provider is giving us us this cable for a certain amount of money so that we can connect to the internet easily, okay? So currently, we have everything necessary to connect to the internet, but office can communicate with each other thanks to the switch. For example, let's say PC goes to the switch, and afterward, the switch learns the destination of the packet, and finally, the switch sends the packet to its destination for us in order for communication of devices in the same LAN. On the other hand, a router has no role in the communication of different devices in the same LAN like PC1 and PC5. This is very vital, okay? I hope I could explain the event. And however, guys, what if PC1 wants to communicate with the internet? In other words, what will happen if it can send packets to the internet? This means that this computer communicates with the internet. Frankly speaking, I believe that you exactly understand the logic of this event anymore. If we can send packets from one to be able to do this first, I mean, if PC1 wants to send a packet to the internet, this packet must reach the router no matter what, because the router is at the switch first to the router, go to the internet, and afterward, cables coming to the router. It's that simple. And the logic behind the router, okay? And as a result, PC1 sent its packet to the internet. In other words, PC1 and the internet communicated. And the device that helps us to connect to the internet is the router. Wonderful. I believe that you understand the most basic tasks of the switch and the router, and I hope the animations have been useful for better understanding. The second question is internet and the router, and I hope you wish that we are going to discuss in the next lessons. See you guys soon.
I want to understand the difference between switch and router. Like switch hub and router. Like I know, like hub, he does not talk about hub, but that has been always a. I know while we learned something, I just memorized it. But difference between a lot of people are confused. With switch but the device that we have at our home, it's called a router. I mean, functionally they are very similar, so that's it's just naming thing. Why is this very weirdly behaving? ASIC. ASIC is are used in blockchain. Okay, software based switches. Routing has, and that's why we call them routers because the ones that we have at home are software have software. Physical data link layer, network layer, then data link network. Yeah, whatever.
Exactly stands for, because if you are really starting from scratch, I mean, I assume that you are real newbies, you may not know exactly what the internet is. For this reason, I want to visualize. By the way, keep in mind that this model you see is a simplified model designed to make the concept easy to understand. And the logic of the event very well, I promise you, and I believe that's for this. So at this moment, I would like to give you another piece of information about a router. A router is a device required for a computer or electronic device to connect to the internet. You know this definition. On the other hand, you can think of the router as the device we use to communicate with a computer in another part of the world. Or you can think of the router as the device we use to communicate with a computer in a different LAN. I mean, if you are aware, there's a LAN here, right? And there is to the another computer located anywhere in the world. I mean, the internet is a structure that connects all the LANs all over. I hope that everything is good so far, but there's a thing. First, you should know that these routers are distributed around the world in other different devices in this net. And information is hidden in the core task of a router to each other, to millions of local routers. I hope you got this. And once you understand the importance of the router for the internet, you probably and something in this picture that should catch your attention. As you can see, these three elements into play, so of the switch and the router. This consisting of a router and switch combination. Hence, these devices in the LANs are a mix of the switch and the router. This means that if we have a home router, we don't need an additional switch and router. It's enough for us. Most of you have these devices in your home and you connect to the internet by using home routers. For this reason, I wanted to tell you what these devices are in order to avoid confusion. However, please note that if there are too many devices in the environment, the home router will be insufficient and you may need additional switch and router. You catch the idea. And now, let's go back to our question. Why there are so many routers instead of additional switch ever in the environment, okay? I showed you a home router because most of you have these devices in your home and you connect to the internet. This is a switch combination. And this is the environment. How can there be a LAN? Or if there is no router in the environment, how can it be connected to the internet? And this is where the home router comes into play. The home router is a combo device consisting of a router and switch combination. Hence, these devices in the LANs.
Okay, home routers are router and switch combination. Nah, That's what confuses us.
are a mix of the switch and like a home or small office. This is important. Don't need an additional switch and router. This device is enough for small environments like a home or small office in the environment. Home routers. For these devices in the environment, the home router will be insufficient and you may need additional switch the single router. Imagine that there is a single around the world and it is impossible to design such a device. But this is not the only problem, because in computer needs to be considered. To be able to teach it better, let me give you an example. We only use, just think about it, it is a router in the middle of the world. And it's a very problem. To make sure you fully understand the main logic of this structure, I want you to do, you can handle this. At the end of the previous
So, like, basically, he says that we can't have one single router because the load will be very high, and then uh, that's why like we have multiple routers that like it goes from one place, then it can find the shortest part.
lesson. And I
He repeats a lot.
know that you were all analyzing the situation, but let's do it together just in case. As you know, if we used a single router at the middle of the world from the giant router, but as you can see in this structure, the cables don't have to be that long, and this is an important advantage. Actually, of course, we can need long cables in this structure too, but not as much as in the other structure. After all, in this structure, there can be many kilometers between two routers. This is reasonable. However, this is by no means laying cables from one end of the world to the other end, right? And while we only connect two routers with one cable in this structure, we will connect millions of lamps to the giant router in the other structure. So, we will need a lot of very long that locate in the router. Everything is good, but what about the load overloading? Since there are many routers, load balance process is very efficient in the distribution. For example, this only its efficiency decreases a bit. On the other hand, when there is only one router for such a huge structure maintenance, with this visual, you can ocean between them. And this visual represents real life itself, unlike the simplified model we use. 99% of all international communication on the internet is provided by these 468 cable lines laid under the water. This is very crucial, guys. Some of these cables are breaking. One of these cables can cause the internet of a whole continent to go away in a flash time. So this red cable, this is an almost 17,000 long cable that starts in France and reaches South Africa. And this cable connects 22 countries on the west coast of Europe and Africa to each other. And this was a definite tragicomic event. In addition to this, as you can crash down when a fishing boat accidentally cut the cable, because we are talking about 1 million kilometer long cables spread all over the world. So there must be something more. As a matter of fact, nearly 200 problems are encountered each year, and these are substantially related to ships or natural disasters. Tall, 11 kilometers of a cable connecting Thailand, Vietnam, and Hong Kong to each other. And they solved this long cable as scrap by dividing it. And I think this event is more surprising than the incredible infrastructure of the internet. Now, I have dividing it, and cables are encountered each year, and these are substantially related to ships or natural disasters. And there's a funny reason that I prefer to use substantially word. Let me explain. In 2007, sea pirates stole 11 kilometers of a cable connecting Thailand, Vietnam, and Hong Kong, and the incredible infrastructure cables generally represent intercontinental connections under waters. But for example, if you look at Russia land, cables are not visible on this image. Please don't be confused about it. Of course, there are cables and routers distributed all over Russia too. They are just ignored in this image. I mean, the main purpose of this image was to show you how devices from different continents are interconnected under the water, okay? Also note that all of these cables under waters are fiber optic cables, because, right? And another reason of why we don't use copper cables is, when the length of the copper cables increases, the probability of errors in data transmission increases as well. On the other hand, even if the fiber optic cables are very long, they transmit the data to its destination almost without error. And this is another reason that why fiber optic cables are used, able to visualize it in your mind. Because no matter what area of IT you are dealing with, you need to grasp this basic subject. Actually, there was something else important lesson. See you guys in a moment. The internet and one was to communicate with this packet, and the packet to the understand that it must set the pattern that is set it the internet, and we'll get a little contact or to discuss every right? All these learn forwarding. As a result, every router needs to look at its routing table to learn which path it must forward the packet. It is very important to know it's created if these algorithms are added 1, 2, or 3. Meanwhile, when a router makes this decision, say, according to the routing table of its routing table to decide which path the packet must go to. Assume that the routing table says the packet must be forwarded, or it will continue to be the same to determine which path the packet will be forwarded. Let's say the router chooses path 1, so the packet will go to this router, right? Wonderful. And at this moment, please listen to me very carefully, because there's a tricky part here. When you look at the paths for the current position of the packet, you probably think of the most reasonable option as path 2, because the shortest path to be able to access this router that is connected to this router seems to be path 2, right? And if we choose path 1, for example, we have to go to this router first, and from here, we can go to this router. Or, if we choose path 3, we will go to this router first, and from here, is this really the case? Let's see it together. First of all, never forget that routers always want to deliver the packet to its destination as fast as possible. So, if this router chooses path 3 instead of path 2, it may seem unreasonable to you at the beginning. I understand that because you decide with a very simple logic. You are just using your eyes. However, routers use many algorithms when creating routing tables. They are not only concerned with the number of points. When choosing the shortest control the traffic of their links, they are connected. There may be an excessive density on the path 2 line, even if it seems the best or convenient. I could get to the point. As a result, the instead of path 2. And we call this situation congestion control, okay? I think the number of points that the packet went through has increased. Let the packet go to this router, and there we go. And this router knows that the packet will go to the LAN 2, and it sends the packet to the rocket came to this computer. So, it sends the packet to the related computer. Wonderful. Seconds, with the device on the internet is one of the most important things that mankind created. I hope I was able to explain intuition of the internet. I believe that you got that. Is the network of the networks. Meaningful to you. Mobile phones, television, right? Enterprise LANs. On this is very much all visual. You can count by only say, okay? And the end of the is the heart in the internet. Internet is a question. Now we are going to discuss the meaning of connecting to the internet office and on its first device, which feature. This should be logic. You have learned that. Now I will try turning on your computer you want to watch. The fact is connected. You want to read this like videos piece by piece. And assume that video being sent to my computer process better. Now I have opened a random video on udemy.com. Piece by piece, we can watch the video without requirement. It's so slow. If you couldn't watch this video before the whole video reached your computer, it will be very bad for you, right? Fortunately, the process doesn't work like that, okay? And in addition, this transmission time is simple. I hope in this way you have a better understanding of what and the home route. In summary, when we enter udemy.com server of normal computers at the same time, access udemy.com when I say, and this is true parts of the world. When you want to enter udemy.com servers, by the way, of course, there are many details behind the guys soon. The wide area network, or briefly WAN, which is a very important type of network for the internet. In a simple manner, you can, or combination with offices expand. We want to same end, but there's an important point to consider here. Thanks to the internet, we can already enable these LANs to communicate, right? As you know, the internet stands for the network of networks. Already connected the quick. Please be careful. Communication over the internet directly and communication over a special WAN belongs to a company is a whole different thing. So, everyone. Any person can connect to the internet. An important transmission process, and which is good. Now, of the part of the internet is an absolute public this issue. Company WAN. There are by VPN. This gives us high security. The important thing, a special limit and security to us by creating a special network connection or packet and high security connection between LAN 1. It's that simple. However, I hope that you got the tunneling conceptually, but there will be some changes on the packet. But before doing these changes, first of all, you should know that VPN tunneling is set up between these routers. This is very crucial, and we call this safe reaches LAN 2. But to explain this, let's say you need to send a letter from suppose you are not this example is the public internet. On the other hand, if you had put this letter in an envelope first and gave it to the postman in this way, the postman wouldn't be able to read it. This is obvious. Hence, the process of putting the letter in an envelope represents the tunneling. It's in the red packet. It's a question. And my question is that, is this packet really in safe right now? I mean, can't the postman open the envelope and find out the information in it if he really wants to? Just think about it. And this is where encryption comes into information. One step, the packet into the red packet, the original packet, and put it in another packet. Your own to be able to do this, the router first eliminates the outside packet, right? And then packet and VPN. We can secure means there may be always a security vulnerability for every system. However, currently, WAN networks built by using VPN technology are quite satisfactory. You probably have these over the internet. So, since the internet is an operation, will be sent as a packet over the internet to one of the servers and to add information about our credit card, obtain the original. The information about your credit card was directly obtained by a hacker in pure text. This is terrible, right? But thanks to end-to-end now, what is the largest wide area network in the world? The answer comes to your mind rapidly, isn't it? The internet itself is the largest wide area network in the world. However, I want to remind you again, please note that a company's WAN created with VPN is different from the internet. While one of would like to say about WAN. See you guys soon. We will look at a few more cases by using these devices. Let's say we have two offices belongs to the same company, and suppose that there are 100 meters between these offices. If you are aware, this distance is very short. In this case, what I am wondering is whether or not we can connect switch 1 and switch 2 directly to each other to create a LAN. And the answer is we can definitely do this, because in the same environment. But please and create a LAN. Meet on university campuses, okay? On the other hand, you know the network, or briefly can, by using WAN with VPN in the animation. And there we go. Yep. Or LAN created by connecting switches directly. Please think about it. The answer is so simple, isn't it? A LAN is always more secure than a WAN, because in the communication is protected in the WAN, the packet still passes over the internet. And as you know, there is never such a methods are secure, but LAN is more secure. This is obvious. By the way, we haven't talked about this WAN type before. I mean, this is different from WAN money for this line. Thus, the ISP gives you a private line that only your company can use. And that's why we also costly. For this reason, it makes sense for an average company to prefer public WAN instead of private WAN. Public WAN provides us. You have already noticed this, but it will be good to mention in any case. We use switch devices to create a LAN, while we use routers to create a WAN. This is we cannot create a WAN by using switch devices, because a WAN fundamentally represents connection of different LANs. With the help of WAN, for this task, you got the point. And now, I want to talk a little bit about the router. Until now, I have always explained the router as an internet-related device. However, it isn't. The main task of the router is to connect different networks. That's it. You should realize that these networks may be in different parts of the world, or maybe in the same office. It really doesn't matter. And it's related to the marketing unit of the company, and the other related to the say that LAN 1 and LAN 2 communicate through the router. Additional information about the router cables is connected to LAN 1, one of the networks, for they are needed within the same office. As a matter of fact, this is a common situation in real life. I mean, you may want different units in the office to be in different computers. Into units, increase basic principles, we can enable devices in different parts of the world to communicate, and that's all. Our previous lessons, I told you, we purchased this cable that came to our home from ISP, but I haven't mentioned what exactly ISP is. And in this lesson, we are going to discuss what is the ISP and why it is so important. The internet service provider, there are a lot of routers in the heart of the architecture. For example, there are doesn't visually show the routers within the ISPs. However, I want you to imagine that the routers distributed around the world are controlled by these ISPs. This is very crucial. Think of it as if each ISP controls specific routers and packet routers. Well, for the simplicity, understand the most of us. So think of ISPs in the world, and all these ISPs, thousands of ISPs in real life, is to communicate with the local ISP, or communication code. If this is the animation, in general, you can think of this scenario, let's say it doesn't. Therefore, one router can be enough to connect them. You got the point. And in this visual, you can see an example of a small local ISP office, and we call these offices point of presence. In this house, so that the device routers on the internet visual were actually representing POPs spread over the world. And in order to explain this better, I want to talk on a different image. But in this image, I want to think of different houses and offices connected to local ISP. A home and small office. This should be to connects different neighborhoods. And in this way, LANs in different neighborhoods can communicate over local ISP to this can only have different POPs. But if a local ISP connects only one neighborhood, it has only one POP. Should be aware that these icons actually represent the router within the POP. There are many POPs distributed all over the world, and routers are we can communicate. I think this is local. Our previous list, a POP over local ISP too. That's the point. And there we go. As you can see, a home and small office connect to a POP over local ISP too. So this POP is the first point to be able to connect to the internet for this home and this office. This should be clear to you. By the way, if you are aware, local ISP2 has 4 POPs. You might think that thanks to these 4 POPs, local ISP2 connects different neighborhoods, and in this way, LANs in different neighborhoods can communicate over local ISP2 effectively. And from here, we can draw the following conclusion. Some local ISPs can have more than 1 POP. However, some local ISPs can only have 1 POP. This depends on the size of the local ISP. For example, if a local ISP connects 4 different neighborhoods, it may have 4 different POPs. But if a local ISP connects only one neighborhood, it has only 1 POP. You catch the idea. And if you want to do more detailed studies on this topic, you will see many resources on the internet with router icons in these POPs. It's that simple. At this moment, this means that different local ISPs communicate over regional ISPs, connect neighborhoods, and regional ISPs connect cities in a country. It's that simple. I won't repeat this again. There is one regional ISP in this simplified model we use, but in real life, a country can have many regional ISPs, and net is local ISP to connect to the internet. Let's suppose that this computer and this computer want to communicate with each other. So in this situation, how will this local ISP communicate with this local ISP? Let's say, in the same country, there we 2 to local ISP3. This is not expected question. Just think about it. If we connect local ISPs directly, the hierarchy is broken. You see very few local ISPs in the scenario, but in real life, there can be many local ISPs even in the same city. And if we connect them all together, complexity will definitely occur. And we don't want to increase the complexity with the minimum number of connections between ISPs. We ensure that all ISPs communicate with each other. It's that simple. What if computers in different countries want to communicate with each other? And this is where the global globes, and by the way, it stays global ISP servers to small companies. And in some cases, these small companies may want a direct connection ISP out of a on will go local ISP ship with see guys. This is our home, and we want to connect to a only one server. This is obvious. You can response file and everything related to the web page. Meanwhile, the server, attention to this, the platform message appears. Web server receiving your request message sends you a response message. All information from this response process happens. And now, let's try to enter google.com instead of ABC Access service to discuss any service from Google. This is the main reason why, and the distributed server structure is a great solution for stage. Google sends us a response message, wants to increase this speed in general. Fortunately, Google is the tech Google connects directly with the local ISPs. Thus, this way, directly to Google via local ISP. In other words, and it is obvious that this direct connection decreases the possibility to be obtained for the packet from Google. So, when you want to watch a video on YouTube, you are actually using Google's distributed servers and be interrupted whatsoever. See freezes and interruptions while watching video structure. Hearing is a good job, is a very effective. Some generally infinite and not as many as in the world. If you have a lot of money, establishing a global ISP company is a good choice. It will probably make you smile with time. By the way, for you in the future. In addition, there are structures called Internet Exchange Points in order for the Internet backbone to work synchronously and for global ISPs to communicate with each other more efficiently. And we briefly call these structures IXP or IX. Never forget that. And the last thing I want to mention is that you don't have to connect to a local ISP in order to connect to the internet. You can directly connect to a regional ISP or global ISP if these ISPs have a service for your location. This means that you can learn which ones, okay? For example, let's say this is our home and we connect to the internet. What the company and talk about what you can do. If you give the required money to the ISP company, most regional ISP and global ISP can provide you the service you want. That's it. But from it. On the other hand, if you want to set up a local ISP company, such as if you want, you can do more research about the ISP on the internet. However, that's all I have to say in this course.
Yeah, this was like the first and second class of a university course. So, like a networking course. So, yeah, basic stuff. I knew most of it, so like kind of skimmed a lot and just skimmed through it. But yeah, nice things. We are done with this. 2 days, 2 hours, I guess, around 2 hours for this. Good enough. 1, 2, 3, 4, like kind of like 2, 3 months of time. But yeah, that's it, I guess. I'm also tired now. In stream.